Good afternoon, all of you. My name is Sumit Bansal. I'm from Godrej Material Handling Business. I welcome you all on the 22nd edition of Storage and Handling Knowledge Series. We started this knowledge series almost 2 years back. We are having this series every month, and we are bringing various topics for our audience to talk about uh, the basic concepts of material handling equipment. Then we also spoke about the transmission, the controllers, the batteries, the safety practices which are need to be done on the forklift truck. Plus, we also spoke about how you can increase safety by putting up safety accessories, and also how you can enhance the life of your equipment by maintaining the equipment with proper guidelines and using genuine spare parts. So I'm very happy that we started in a COVID era, and we were averaging about 150 to 200 attendees during that time. And this is the first event where I believe most of offices are open and people are working from office, not from home. And we are till now more than 100 plus attendees. So this gives us a confidence to do more and more webinars and interact with all of you, and bring some positive notes for our reviewers so that they can implement, learn, educate to increase the safety and knowledge and storage and handling series. So having said that, today we have a very interesting topic. It is about storage solutions. India is a place where about 50% of the land is prone to seismic zone. And this is a very interesting topic. And in order to discuss about this, we have Mr. Nagendran from Godrej Storage Solutions, who has a wide experience of 18 years. He is a head of new product development and research, and he has its expertise in developing this product design and development. He has been working on the solutions for seismic zone storage for more than 10 years. And he is very result oriented and has done various experimentations to come up with a product which it is available as of now. As a company, we have done a lot of installations, and he is expert in intralogistics space. So before taking any further time, I would request Mr. Nagendran to take over and give us insights of storage solutions specific for seismic zone. Over to you, Mr. Nagendran. Thank you.
Thank you, Sumit. Thank you for a very nice introduction, and good afternoon all. Hope my voice is clear. So today the subject of discussion is on the racking solutions for seismic zones. So the specific focus here is on how do we really make the racking structures resistant to earthquake. So there are broadly 4 parts in it. We will look into some basics of earthquake, and then how it can impact a racking structure. So how do we really design a structure to be resistant to earthquake? And the last subject is a little interesting subject, like if suppose a structure is not designed originally, considering the earthquake efforts, is there a way that we can make it seismic resistant? So it's called as retrofitment procedure. So there are 4 parts on the presentation today. So let's move into the first part. What is an earthquake? So just some basics of earthquake. So earthquake, what we understand is, it's like the shaking of the surface of the earth because of an energy release inside the earth's core. If there is a shake on the surface of the earth, it's called as earthquake. So it is a set of waves that gets transferred on the surface of the earth. That is called as earthquake. Now there are few critical terms that we used to hear. So I thought I'll introduce you to those terms. There are 2 critical terms, which is called as focus and second is epicenter. Focus is the place inside the earth's crust, inside the earth's crust where the energy releases first. where the earthquake originates. That point is called as focus. And the point exactly on the surface of the earth, where exactly on the surface of the earth, in line with the focus, is called as epicenter. So many times we used to hear the earthquake has happened in a particular zone, so much of distance from an epicenter. So this is how we used to hear. So that is the relevance of the term called epicenter. So when we say the seismic waves, so there are how many types of seismic waves are there? So broadly, they are called as body waves and surface waves. So what are body waves? Body waves are something which is seen inside the core of the earth. They are called as body waves, and surface waves is what we feel on the surface of the earth. So when you say body waves, there are two waves. It is called as primary wave and secondary wave. Why they are called primary waves and secondary waves? Because in the seismograph, what gets recorded initially, that's the primary wave, and secondary waves take some time in reaching the point. So it is called as secondary wave. And when it comes to surface waves, again, we have two varieties. One is Rayleigh wave and Love waves. So this is how normally seen. Many times people normally discuss about three waves. Love wave is something which is little insignificant, but still it is better to understand what is a love wave also. When we go to primary wave, which is at the earth, core of the earth, means inside the earth's surface. So the movement in which the direction of this primary wave is in line with the direction of the force propagation. So that is how the primary wave is seen. When you go to secondary wave, this is more like this movement of the secondary waves is in the orthogonal direction of the energy release. It could be either up and down or it could be on the sideways. So that is how the secondary waves are classified, but these two are inside the earth, so may not be felt on the surface of the earth. What gets felt on the surface of the earth is the Rayleigh waves. Rayleigh waves are mostly again elliptical waves, and again they have effects on the orthogonal direction of the movement of the wave. So that is how Rayleigh waves are seen. Love waves is again like it is again in the orthogonal direction, but they have a very limited effect on the surface of the earth. That's how the different types of seismic waves are seen. Many times people record primary, secondary, and Rayleigh waves. When it comes to the kind of energy release that happens, Rayleigh waves contribute to almost 67% of the energy. Maybe another some 26% is around primary waves, and it is secondary waves are also very significant. So the major impact is felt through Rayleigh waves. This is more of out of academic interest. When we move inside, many times we hear a term called Richter scale. So what does a Richter scale mean? It is like, this is a measurement taken from a seismograph. So it is the measure of an amplitude. It is measured in the logarithmic scale, and it is a measure of the amplitude of the seismic wave that is recorded in a seismograph. So what does it signify to us? So in a Richter scale, suppose if we say a Richter scale of 4 to a Richter scale of 5, the impact is 10 times. Many times we feel it is a single number. One number increase, what could be the effect? Because it is on the logarithmic scale, the impact of Richter scale is 10 times. So scale 4 to 5, the impact is 10 times. When it comes to energy release, it is almost 30 times when there is an increase in Richter scale 1. So that is the huge impact that we have when it comes to Richter scale. So that is the significance of Richter scale when we are talking about measurement of an earthquake. Some little interesting stuff on this earthquake. The largest earthquake ever recorded is recorded in Chile in 1960 with a very high Richter scale of 9.6. So around 20,000 earthquakes are getting recorded every year around the world. So how much time an earthquake normally lasts? It is around 10 to 30 seconds. So the maximum is 30 seconds. So that's what an earthquake can last about. So there are around 900 earthquakes recorded in India in a year. Around 6.6 is the magnitude that we have maximum recorded so far. Moving ahead. So how do we see India as a seismic prone area? So Indian seismic zone, there are 4 zones currently. Originally there were 5 zones. Zone 1 and zone 2 got merged. Then we started doing it with zone 2. So it is zone 2, zone 3, zone 4 and zone 5. There are 4 zones in India. So zone 2 is the lowest and zone 5 is the highest. So zone 2 is very less active. So it means when we say these zones, how they are classified, it depends on the amplitude of these seismic vibrations and the frequency in which the seismic vibrations can happen. So that is how these zones are classified. So zone 2 being the least and zone 5 being the highest. That is how it signifies when it comes to seismic zone in India. So in terms of Richter scale, just to give some reference, when it comes to zone 2, the Richter scale is around 5, less than 5. Zone 3, it is between 5 to 6. And somewhere when it go to zone 5, Richter scale value is between 6 to 7. And zone 5, it is above 7. There is no direct linkage, but in a way, they are representative values, just to get a clarity. When you see, there are some potential epicenters that are plotted across India. So if you see, across India, there are multiple epicenters plotted depending on the past recorded earthquakes. So there is a very high chance that when we are going on a structure, one of our structure falls on one of these potential epicenters. So that is the criticality that we have to see when we are designing a structure in India. So what is its impact on the racking structure? Why do we have to be worried about seismic? Is something that we will see now. Now, what you see here is a racking structure. In general, racking structures are designed only considering vertical loads. What arrow marks you see, in structural terms, it is called as gravity loads. So they are designed only considering vertical loads. So what happens when it is a seismic? So what we see here on the base plate on the bottom is the earthquake. So what happens? The earth starts moving at the base. So now this gives a reaction along the structure. So what starts here at the base has got a reaction along the height of the structure. So this lateral forces, if not adequately considered in the design of the structure won't work. So this is one clip that is recorded. This is a footing of a CCTV recording inside a warehouse. So probably we can see this was taken during an earthquake time. You can see a person running over here. How a racking structure can fail in the event of a seismic. So that is how you can see the shake slowly getting increased and the racks shaking. So though it is minor, we can still observe it. In seconds, if you see that the rack collapses. And this will be little in real time. If somebody doesn't observe it, it can collapse immediately. So this is the effect that can happen if the structure is not adequately designed. If you see, the complete system has collapsed. So this is what can happen. If you see here, this is how a rack structure can collapse if it is not adequately designed considering earthquake forces. And many times one structure collapses, it induces failure on the adjacent structure also. Even that progressive collapse effect also can happen. One portion of the rack collapses and it can have an effect on the adjacent structure. So we have to be careful that the complete structure is kept intact. So how do we really design a system to be resistant to seismic? So there are two ways. One is we can resist the forces that are getting induced during seismic. So that's what you see here as a first step. Second is a method of different method of dissipating the energy. So how do? We isolate the structure from the ground, and then we ensure that the structure doesn't collapse by dissipating energy here. So the point one is more of resisting the forces and energy that is released during earthquake. Second is dissipating the energy at the base so that the structure doesn't fail. But in the current stage, the base isolation systems are not very popular, though it is being done in many buildings. It is most of the time little difficult to implement because it has to be very specifically designed and very critical in terms of detailing and execution. So the widely adapted practice is resisting system, where the seismic forces are resisted. That is how the system is designed in the current practice. So how do we really design that when it comes to earthquake resistance? How do we really design it? So there is a standard available in India. How do we design a structure for an earthquake resistance? The standard is called as IS 1893. But here this one is, this standard talks, there are multiple parts and each part talks about a different system. The part one is on the general provisions. When we go to part two, it is like the water tanks or the tanks where other liquids are stored. It is again for bridges. Part four is for industrial structures. Industrial structures are more like chimneys, industrial buildings kind of stuff. And part five is for dams and embankments. But in none of these parts cover racking as a structure. So that is one small gap we have. When these structures are all designed as buildings, Racking is a little special structure. So they are not covered in this IS 1893. So we have to definitely use IS 1893 when we are designing a structure in India. But IS 1893 alone is not good enough. We need a specific code on racking, which gives provisions on the racking design. So moving forward, how do we do that? So in the current state, there are no standards available in India for the design of racking system. So we have to look at either Europe or America for the purpose of the design. So globally, there are 3 design standards available. From Europe, it is EN 16681, which is a standard for the design of racking system for under seismic conditions. Second is from US, which is ANSI MH16. In general, it is called as RMI. This is a complete standard for the design of racking system, and it has got classes that classifies how do we design racking system for seismic resistance. And the last standard is from Australia. This Australian standard is based on these 2 standards, European standard and an American standard, but it has got the classes explaining how do we design a system for seismic resistance. So there are 3 standards available globally: Europe, US, and Australia. So we are forced to adopt one of these standards and use it along with IS 1893 when we are designing our racking system. One simple, this one of how these racking codes are evolved. So somewhere during 2004, research was conducted on the racking structure for their behavior under earthquake. So how do we do that? The first project was called as CSRAC 1. So they studied the behavior with that the standard of FM 10.2.8, which was more of a manufacturers association standard evolved. So after a few years, after seeing the behavior, they conducted one more research, which is on CSRAC 2. So the result of CSRAC 2 is the standard, which is EN 16681. So if you see, approximately it is the standard has got almost a decade's research. To be precise, it is 12 years research. And in the current state, this is one of the most evolved standards on the seismic design, EN 16681. So what does it say? So how is it really different when we go to a racking standard other than a simple structure? So what happens? The racking standards are special structures because the columns are all made of thin gauge steel, and they are all completely perforated to offer flexibility when it comes to adjustment of the system. So many times, if you see the kind of customization and the flexibility that we have to build in the system, it needs customized profiles to be built. And to build the customized profiles, the best possible choice is the cold form steel. And being cold form steel, they are thin gauge, so that is how the challenge builds. So the section behavior is completely different from any hard road structure. So that is the very first point in this very first challenge in the design of a racking system. And the second is the connections. So all the connections are all special connections. They are not classified under any of this standard structural connections. So though the behavior of those connections under earthquake is very important. So the behavior of the connections has to be precisely modeled into the system when we are analyzing or designing it. So at the same time, when we see the structure, because it is made out of thin gauge steel structure, thin gauge steel, this self-weight of the structure is very light compared to the goods stored on it. So it means the structure on its own cannot offer any great resistance against earthquake. So that is one part we have to see. The mass stored is very high, whereas the self-weight of the structure is very low. So the structure on its own can't damp or resist the forces. And the third one critical point what we have to see is the goods stored on the structure and the interaction between the goods and the structure. They are very critical points to be seen. So there are these parameters makes racking structure a special structure to be carefully designed, especially when it comes to seismic. Now, what is this interaction between the stored goods and the structure? So if you see a pallet racking system, the racking structure is the physical structure, and we have the pallet stored on it. So if the material of construction of the pallet changes, then the behavior of the structure, overall structure changes. So what is the difference? If the material of construction of pallet is wood and steel, the friction coefficient is very high. So the pallets won't move much. It means in the event of seismic, the pallets can put a lot of force on the structure. On the other hand, when the pallet is made out of plastic, or steel, the coefficient of friction between this pallet and the steel is very low, making it to slide in the event of seismic. Energy gets dissipated at this junction. What we are talking is in this junction. Between the pallet and the steel, if the friction is more, the pallet can't move. So force gets exerted on the structure. If it is plastic or steel, they may slide and the energy dissipation happens at this junction. Hence the force exerted on the structure goes less. So this is one critical point. That is something has to be taken in consideration when we are designing it. So if we don't know it clearly, either we may design a structure which is unsafe, or we may design a structure which is over safe, and hence there is no, it's costly or it is not economic. On the other hand, one is on the material of construction of the pallet. On the other hand, the goods stored itself can have an impact on the structure over which it is stored. So, for example, if you see here what we call it as Class A and Class D, we see Class A and Class D has got worst effect on the structure because these are solid components. If you see Class A, it is quite solid and it is compactly packed. It means it acts as a single entity, and in the event of seismic, the complete object acts as a single point at the centroid, and the complete force gets transferred to the system. On the other hand, if you go to Class D, which is liquid, the splashing effect of the liquid exerts lot of force on the structure. So normally liquids are very dangerous in the event of seismic because the splashing effect puts lot of extra effort on the structure over which it is stored. So these two are little critical when it has to be seen. On the other hand, if you see Class B and Class C, these are independent boxes or bags stored one over another. There is a very high chance in the event of seismic that these boxes move relative to each other, or these packs move relative to each other, and energy gets dissipated, and hence the force put on the structure goes little less as compared to these two structures. So if you have clear information on these also can be clearly accounted in the design. Now coming to the other factor, soil type of the structure. So on one side, when there is a seismic zone, the locality where the facility is built, depending on the soil type below, the structure can experience different levels of forces. Say, for example, if you see the solid bedrock, it has got a good damping effect. In the event of seismic, the force transfer to the surface becomes very less, and the structure that is built over the solid bed experiences less forces. Once the solid becomes softer, say for example, of solid bed we build to a medium soil, the level of forces that gets transferred to the structure goes little more. From solid bed to the medium soil, it goes more, and from there moves to the next level where it is soft. The forces experienced are very high. So that's where we see here from hard to medium to soft, the force experienced by the structure goes higher. So this becomes very important. The right kind of solid soil type is considered in the design. See, most of the time when the structures are built, the soil test is done, and this information is very important when we are designing the structure. So in the event of no information available, normally the design is made considering medium soil, but many times it could be little unsafe or it could be little over designed. So that's very important to know the right soil type. So here you can see the seismogram records. For example, for the solid bed, if you see the amplitude is very less. When we go higher, it goes more, and when it becomes softer, it further goes more. So this is how a soil type can impact. So these are few examples on why the racking system becomes very critical. What you see here is a base plate design of a racking system, where if not adequately designed, if the joints fail, the overall structure can give off very easily. So it's very critical that we design the structure correctly. Every joint is detailed correctly. So if there is a failure in the base plate, the complete structure can give off. And this is one critical failure that can happen in the bracing system. If not adequately designed, many times it can so happen that the bracing fails and the complete structural integrity is lost. One of the point that is generally ignored is this bracing connection, which most of the times people don't detail it correctly. So what happens? The failure can start here. Once this gives off, the complete structural integrity goes. So critical connections have to be designed and detailed properly. Moving forward. So how do we really design this? So what happens? We have to there are three things that on which the design of racking structure is done. So what happens? We have to really comply to a design standard. Probably depending on the country, we have to definitely select the right country annex. Then we have to choose the right racking design for the purpose of taking the force calculations. Then the structure has to be completely analyzed, incorporating the forces, proper combination of forces. So one critical thing is we have to comply to a right standard for the purpose of the design. Many times, when we are analyzing the structure, we need a lot of experimental results to be incorporated into the analysis model. One critical such information is the behavior of the connection. What we see here, this joint is a very customized joint. So if, for example, the stiffness value and the moment capacity of this connection has to be properly fed into the model, so that when we are analyzing the structure is a very realistic structure. And this, like for example, we have a strong partnership with academia and industrial experts. So we keep understanding the improvements and gaps in the design, then we keep improvising it. So this is how we do the seismic design. So what happens when we do a seismic design? How different it could be from my regular design? So what you see on the left is a regular racking structure, plain and simple SPR. It has got a set of frames and beams loaded. So when it comes to seismic, this structure alone may not be in a position to take the load. So depending on the design, the upright section can go a little bigger because the frames have to take more load in the event of seismic. Those two, the lateral loads are being subjected. So non-seismic could be a section and seismic may be a little bigger depending on the kind of configuration what we are doing. The base plate has to be detailed properly. The base channel, what we do normally offer in a regular structure may not be adequate to take care of seismic forces. The channel height, the welding and the base, everything changes when it comes to seismic. We may have to provide the bracing systems so that the lateral forces can be countered properly, and the anchor bolts have to be selected properly to ensure that they don't give off in the event of seismic. There are seismic rated anchors available, and it's very important that only seismic rated anchors are used when it comes to seismic design. The regular mechanical anchors won't work, because these anchors have to withstand the vibrations that happens during seismic, and hence the selection of right anchor is very important. So this is some research that we did. Say for example, so far all our designs are purely based on the codal provisions and the analysis on the software. So it was becoming very important for us to understand how does a rack behave when it is subjected to seismic. So research work was conducted. This research was conducted in collaboration with SERC, which is Structural Engineering and Research Center under CSIR. So we subjected the racking system to a set of static tests and subsequently to a dynamic shake table test, and then we studied the behavior of it. Now what you're seeing here is a racking structure installed with the regular frames and then loaded. It was subjected to a lateral load using a jack. What you see here is a jack. The structure was completely pushed laterally to see how these joints behave in the event of seismic and how the base plate behaves. So this was conducted in multiple different directions. We call this normally as down eye, the direction parallel to the beam, and cross eye, which is parallel to the frame. So the orientation was changed and repeated connections were studied. So in this orientation, the beam connection and base connections were studied, and in the other orientation, the frame connections were studied. This is how it was done. So this is on the static test and the behavior was recorded. So subsequently, we subjected the structure to a shake table test. See, we normally, if you see in India, the standard goes as 0.36 G, which is zone 5, which is the highest possible acceleration in India. So we tried little more than that even. We went till say 0.5 G, which is little higher than the maximum acceleration specified in Indian standard. So that is how the structure was subjected to a lateral load, and the study was made. Probably I can take you through a simple video how the structure was behaving in the test. This is the shake table test that was conducted. So what you see here in yellow is a support structure which was constructed considering the event of any failure. How do we really ensure that this structure doesn't collapse on the frame? Otherwise, this is the racking structure. complete structure was put on a shake table, and then it was subjected to the acceleration starting from 0.g and went till 0.5g in slow increments. If you see the complete structure after the test still remained intact. So this was subjected, we went as high as say 1 minute here, maximum we went till 1 minute, though the maximum recorded earthquake was only 30 seconds so far seen. So we could not, we ensured that no, the structure, there is no failure in the structure after this shake table. So what we are saying is how do we really say that no, the reliability of the design is ensured? One, we ensure that the system is designed based on the standards, globally accepted standards, and all necessary inputs are taken from test, and then they are properly incorporated into the analysis and the design procedure. And in a way, we have tested and seen also how does our design work in the event of seismic over a shake table. So this gives one level of confidence that no, the system, the design works well. And one more doubt we always had was what can happen to the SKU in the event of seismic? Can a pallet fall? So one thing what we tested, if you see here, one thing what we observed was in the event of seismic, we had a doubt whether the pallet can fall. So if you see here, even the pallets were not moving very much, especially for this wooden pallet. So that was one point that we were gaining also. The way it is designed, so the wooden pallets also cannot fall much. So that's how we were seeing. This gives you confidence that the structure can work well without any danger in the event of seismic. So one point here, say for example, today when we are designing this structure, there is one, if you see in the Indian context, there is no strict guideline available when it comes to the design of racking system for seismic. So there are many chances now. Today it is seen as an optional design when it comes to designing a racking structure for earthquake resistance. Many times it's an option. But it is very important that no, the structure is designed considering earthquake effects, because we will never know when an earthquake can happen. And if it happens, it's important that the structure and the people who are working around are safe in the event of a seismic. So that is something that has to be critically seen. Now, when we see it here, is it like new systems? Yes, definitely it can be designed. But is there a way that systems that are designed in the past, when maybe in the past there was no consideration made for earthquake resistance, is there a way that these systems can be converted into seismic resistance? So there is a way by which these systems originally that are not designed considering earthquake effects can be made to work for seismic resistance. So we call it a seismic retrofitment. This is a technique which is normally adopted in the buildings. Many old buildings are maybe retrofitted with necessary strengthening elements to make them suitable for seismic resistance. So a similar, this one is adapted when this is something that we have tried applying to our racking structure also. So how does it work? So there are three steps that we have to do. One is evaluation of the existing structure, analyze and design of the structure, and then how do we really strengthen it at the component level or even at the structure level. So that's how the approach is at three steps. So what happens, this is being an existing structure, it becomes very important that we evaluate the condition of the existing structure. So one is as a structural, the complete structure, we have to be sure that the structural integrity is good and the structure can work further. And second thing is one more information which could be of very good uses, like in the event of designing the structure, say for example, a few years back when we designed, it could have been designed for a particular pallet load. But moving forward in the regular practice, they may not be loading it for the same level of load. Say, for example, a system designed for 1000 kg, probably they are using only 700 kg or 800 kg in the regular practice. So this information can be, if it is available, that can be used when we are trying to really strengthen a system for seismic. So this is, we call it as the possibility of mass reduction. So that is very important. And second, the condition of the material. So what was the material property used for that structure? If we can really backtrack it, say for example, whether the upright was designed with a steel which is say 355 MPa or 400 MPa or 450 MPa. So that really helps to see whether that benefit can be leveraged today. So that way we will first check whether the structure is now really suitable for being designed to be retrofitted. And second, we can assess the capacity, how much cushion available, and then definitely we can see. When it comes to analysis and design of structures, over and above the regular standards that we use for the analysis and design of racking structure, there are two other standards which we are trying to apply. One is like an IS standard, which talks about how do we really evaluate and repair a structure. This is, though the standard talks about predominantly for concrete buildings, the philosophy is still applicable even for a steel structure. So we still see how do we really apply this, the IS standard 15988. And the Eurocode 8, which we call it as EN 1998, also talks about how do we really assess a structure for its earthquake resistance, and then how do we really retrofit it. So that is again still possible. So these I would say the recommendations of these standards have to be applied to evaluate the suitability of the structure for retrofitment, and further the structure can be designed applying the regular design standards for racking, and it can be retrofitted. So what you see here is how do we, there are multiple ways that we can strengthen it. There are some of the examples here are, say for example, the frame being the very critical member of a racking system. The upright can be strengthened by adding certain retrofitment elements, like adding certain channels into the structure. The bracings can be added. Extra bracings can be introduced to make the frame stronger. The base can be strengthened with adding a certain struts extra, and extra anchoring can be done. And the extra row connectors can be added to the frame to make the DF frames stronger. The bracing systems also can be retrofitted. There are ways in which this can be added into the existing system, both plan and back bracing, and hence the racking can be strengthened adequately to meet the requirements of the earthquake forces. So when we do this, depending on the age of the structure, codes allow us to see how much forces we have to take, considering the expected life of the structure after this retrofitment, and hence the system can be designed accordingly. This is how a retrofitment system works. So there are certain information to be captured when it comes to the design of the racking system. So what we need is one thing is the location, the precise location of the warehouse. So it will help us in knowing exactly what is the zone and what kind of forces that we have to consider. What is the type of soil when it comes to in the site of the structure, where is the type of the soil? Once we know the right type of the soil, we can consider it in the design. What is the material of construction of the pallet? So if it is wood, steel or plastic, then accordingly we can decide the interaction between the pallet and the structure. And what is the type of SKU? Again, as we saw in the past, whether it is a loose box or a single block, or is it a liquid, that can definitely help. The grade of the concrete, which is very important because it helps us in deciding on the design of the base plate and the anchor bolt. Because the base plate and anchor bolt interact with the floor, the grade of concrete becomes very important. If there are any additional rackings, rack sprinklers or something to be planned to be added in the system, it's very important that we have that information so that they can be adequately considered in the design. And the next item is what could be the, because no, this structure is put inside a warehouse, there is a very high chance in the event of seismic, these two racks, the structures interact. Say for example, our racking system and the warehouse building may interact. They can come together and then interact. So what could be the maximum displacement of the building? So in that case, no, we can design our racking system in such a way that these two don't interact. They don't touch each other in the event of seismic. So if we have all this information available, it is very much possible that no, the system can be designed for the seismic resistance. So mostly our designs are within India, but there is a possibility that definitely the designs can be extended even to the geographies outside India. We currently do seismic designs even outside India, so any geography it is possible. So just to give a conclusion, earthquake is, though, for example, it cannot be a daily event. It's not a daily event at this point in time. When it happens without any warning. There is no predictive system today, as on today, to know whether an earthquake can happen or not. So it is very important that the structures are designed adequately. Rack systems, if they are not designed properly, definitely they can collapse in the event of seismic. So it's very important that we ensure that the rack systems are designed adequately to resist this failure. So the system has to be properly designed, and it has become very important that the design is done using an appropriate code. Hence, we are very confident on the reliability of the system. Systems that are originally not designed, definitely there is a possibility that they can be retrofitted and strengthened to make it resistant to seismic. That's from my side. Thank you. Thanks all.
Thank you, Nagendran, for the very useful insights related to storage solutions when it comes to seismic zones.
Yeah.
It was covered very well, and the way you went through by stepwise, I think the audience would have definitely find it interesting, and a lot of new information would have got to the people. So we have received few questions from the audience. So I'll take one by one.
Yeah.
So the first question is that, are these seismic racking system effective for both tectonic and volcanic earthquakes?
Tectonic and volcanic earthquakes.
Yeah.
See, there are two things. Normally, tectonic plate movement is a terminology used when it comes to the effects like that happens under ocean. And volcanic vibrations is like systems adjacent to volcano. So normally the design that what we are doing is predominantly based on the earthquakes that happens on the land surface, the regular earthquakes. So special cases, tectonic and volcanic, I may have to check. But the design doesn't cover those areas. It is normally on the earth surface, which is covered on the basic earthquake that is happening on the landscape.
So the second question is that, does the design also depends upon the last loading level in a warehouse?
Yes. So what happens, a structure, say for example, different structures react differently for in the same seismic zone. So what are all the parameters that define it is, like for example, the load that is stored on the structure, the height of the structure. So the mass that is put in each level and what is the load on the last level, that definitely decides how a structure will react, and hence it has a good impact on the design of the structure also.
So Nagendra, the next question what we have is, what would be the approximate increase in project cost for a normal racking system versus seismic racking system?
See, it all depends on the kind of racking system that we are talking about. Maybe just to give a thumb rule, it can definitely change depending on the configuration and the kind of building that we are putting into. What I'm giving is a very ballpark figure. For a simple pallet racking system put in a zone 4, the increase could be somewhere around 15 to 18% over the regular design. It's a ballpark figure.
Okay. So that's not very high if we consider the safety of the people and the material which is put in.
Correct.
So the next question is that, is there any agency, you did mention that there is no current guidelines in India.
Correct.
But Godrej being a leader in storage solutions, are they working with any government agencies to frame the guidelines, because it is a very important aspect towards safety? So that's a very interesting question from one of the audience.
Okay. We are attempting something, but it is at a very primitive stage. So very primitive stage, but it needs a lot of coordination with the industry people, academicians and all. But currently we are at a very primitive stage. Yes.
Okay.
The biggest challenge is there is no standard in India at all for racking design. Even before we move to seismic, the basic structural design standard itself is not there in India. And the second challenge, many people who are into the design of steel structures will know, the cold form steel design code in India itself is not revised for years. It's like IS 801, IS 801 we call it. That revision is also still going on. So the cold form steel design code itself is not updated in India. So that is again one more challenge today. Even a cold form steel structure, what we are designing, I think apart from racking, many people adopt other standards because the IS standard is not revised yet. So it's a little long way for us to take it in India, but we are working on it.
I think I'm sure it will be done because the way the warehouses are going up and the logistic companies are coming up, it will definitely be taken up. So the next question again is that can this systematic racking system can also be incorporated for very narrow aisle trucks like TSPs, stock pickers, and articulated forklift trucks?
Yes, possible. Very much possible.
So the next is that, is it also possible to design mobile racking systems for these zones?
Yes, it is possible. One challenge there is the mobile racking system. There is no direct standard available because, for example, if you see the standards available are all for the static racking system. See, not static structures for that matter. Many times mobile systems don't need a great I would say focus in terms of designing it for seismic, though yes, in few occasions it could be needed because anything that moves doesn't fail in the event of seismic. If you would have observed, anything that can move doesn't fail. Items that are static will have a problem. But yes, your question on mobile shelving, at times what happens, this mobile shelving can move in one direction, or if it is locked, what can happen? So there are certain concerns. Yes, mobile shelving systems can be designed, but there is, in the event of there is no standard available directly. So it could be like some inputs from the standards and some first principle design we apply and then we design it. It is possible. There are extra safety hooks that are provided to hold the system with the rail. It's possible.
So Nagendra, the next question is that we see that racking is also done on mezzanine floors or first or second floors. So the question is that is it possible to have seismic racking system on mezzanine first or second floor system floors also?
Yes, possible. It's possible. Only thing is there are 2-3 points to be taken care of. One is because the racking system is designed at an elevated level. Most of the times, if I have to understand this question correctly, many times the systems that are installed on the mezzanines or multi-tier mezzanines happen to be single-tier shelving systems. They may not be heavy racking systems. They will be single-tier shelving systems. So, given that fact, the systems are light duty, and then the load on the structure and the height of the structure both are small. So the impact of seismic on them is very minimal. So it is easy to make them resistant to seismic. So that is possible. So they don't have loads as high as what we have in an SPR system. So shelving systems on mezzanine and multi-tier mezzanines, it is possible to make them seismic resistant.
It means it is also possible for drive-in racking systems also.
Very much possible. Drive-in racking systems can be designed for seismic resistance. Very much possible.
So now one question is that maybe he could be a warehouse productivity manager, that do seismic racking system has any impact on pallet positions than standard racking system?
No. See, that is why if you observe, the bracing systems are all taken in a space which is on the rear side of the system. Most of the conditions, maybe yes, there is a very remote chance considering the size of the layout versus the pallet size. There is a very remote chance that some pallet positions can be lost, but many times we can design it in such a way that we don't lose pallet positions. To answer your question, it is never no space is left. Say the bracings are not done in a way that your loading unloading is impacted. So because we are putting bracing, some extra clearances are needed in certain areas. But most of the times what we have come across is this bracing systems doesn't reduce the pallet positions. So if there is a condition where it is happening, we have to definitely see and come out with a method by which it can be attacked. Most of the cases it doesn't go. It could be some rare cases where the layout of the warehouse building versus structure, there could be minor impact on the pallet positions. Otherwise, on an average, it doesn't impact.
So the next question is that if as a customer,
Yeah.
I would like, if I want to go for seismic racking system, as there are no standards available in the country, so how am I assured that the solution given is certified solution?
Yeah. So it is like this. Yes, there is no standard available in India, but definitely the design is in line with a standard which has got a strong base on research over years. So anybody who checks the design, they check it against the standard which is, you say, for example, an European standard or an American standard. So we design it definitely based on a standard, and which is again has got a strong base of research for a decade. So that is the conference with which we are approaching. Even the institutes like IIT, they check these designs only based on European standards. So it is a general practice in the industry, not just racking, but even in the structural industry, to adapt European or American standards. And that is very well certified also, even by a reputed institute like IIT. That is an acceptable.
So as a follow-up question, so if someone wants to go for a third party certification, so you're saying it's possible to
Definitely
be
possible.
carried out in the country itself?
Definitely possible, yes.
Okay. So yeah, there is one more question that is there any special requirements for cold storage modification or the cold storage racking systems when it is to be given on seismic zone, which is especially for 4 and 5? Seismic zone of 4 and 5.
Yeah. No big special requirement. No big special requirement. Can almost the same things can be adapted. No big requirement we have seen. The only thing is the chance that in a cold room, many times the friction between the pallet and the beam could be little lesser than what we see in a regular warehouse. So that is one area that we have to give little attention. Otherwise, the approach is the same. No big difference.
Okay. So, Mr.
There is
Nagendra,
only one question here. Suppose in being cold room, if there is a possibility of change in weight or an increase in weight, if you assume that information has to be shared with the rack designer. Otherwise, as long as the weight of the pallet and the size of the pallet remains correct, the design approach is almost the same. Yeah.
okay. So we don't have any more questions. I think there were pretty good questions from the audience.
Yeah.
And you have answered very well and very in a systematic way.
Yeah.
So I would like to thank you for making this presentation, and I'm very sure that the audience who is with us today would have got useful insights. And once again, I thank you. And to the audience, we will once again come back next month with a new topic, with a new expert, so that you get more knowledge about storage and handling. Thank you very much.
Thank you, Sumit. Thank you all. Thank you.
Please share your feedback